So here's what I want to do. We're going to do a perpendicular line. Example number 3, perpendicular line. Now you guys know that when I draw the symbol, I mean perpendicular, right?
Yes.
You do now. All right. So again, we're going to have our ruler. We're going to have, oops, I don't want that. Yikes, delete that. Wrong one. That. All right. So now, draw a line. I'm just going to draw a point here. Some random point. So now what you need to do is you're going to take your compass and the pointer and put the pointer right on the point. Like so. Let me change the color of that. Now to make a perpendicular, we need a linear pair, right? So when I make an intersecting ray, a ray that intersects this line, or an intersecting line, it's going to create a linear pair, correct?
Mm-hmm.
So I need to make sure that the angle on the left is congruent to the angle on the right. The best way to do that is to make sure that when you construct this angle that it's equidistant from the center point. Okay, that's a very informal way to say it, but what we would do is we're going to make a little arc here, not changing our distance, rotating completely around, and make a little arc here. Okay? So now what I've done is those two arcs are equidistant from that point. They're the same distance. Why? Because they're basically the radius of a circle. Right? Does it matter what size the circle is? No. So now what I'm going to do is I'm going to change colors again. And from there, I'm going to make, well, let me turn it around up here. From there, I need a little more room, I think. Yeah. From there, I'm going to make a bigger circle. So what I'm going to do is I'm going to extend this. I need to make sure that this crosses over the center point. Okay? So you can measure it sort of like this. Do you understand what I'm doing? I'm going to put my pointer at one of the arcs. And I'm going to make sure that it extends over the center point. Okay? Change your distance now, yep. Well, you want to change it in a way that it extends over the center point, right? So don't make it shorter, make it wider. All right, so now I'm going to make a little arc. Do not change your distance. Do one at the top and one beneath, making sure that you cover that center point. Now what we're going to do is put our pointer on on the other arc, and I'm just going to do this. Do you guys see how I did that? Now what do you think is going to happen if I draw a line through those two intersections?
It'll be perpendicular to them.
It'll be perpendicular. Let me explain to you guys why, okay? Here's what's going on. You guys don't know it, but we've actually, if I go from here to here, and I go from here to here, I've actually constructed an isosceles triangle. Okay?
Really?
And the altitude height of an isosceles triangle always comes from the vertex or the peak of the triangle down to the center of the base. So when you think about this, this is the center of the base. In other words, and there's about 4 other ways that we can explain that that is in fact equidistant, or basically our angles will be the same. They'll be 90-degree angles. So now I'm going to come over here with my ruler and try to intersect those, and look at that. It is exactly 90 degrees.
Wow.
I know what you're thinking, amazing. Okay. Now, if we wanted to measure that, we certainly could. What do you guys think?
I'm thinking that I understand. It's just if I were to do this on my own, there's no way where I could like be like find the perpendicular of this. And I would be so.
Well, that's why we're here. You're
But
learning that.
I understand everything that you're saying,
Okay.
and I like the steps aren't hard. It's just if you were to totally do it on my own, I don't think I could.
Especially due to
You
these
can't. Yeah, I just did one example. So yeah.
especially because these protractors
Yeah.
are